Hi and welcome to Maths class. Today we're going to start looking at non-linear graphs. So that means any graphs that don't make a straight line. So when we have a straight line, we have something like y equals 3x minus 2. And we know, because we've done a lot of those, that we can work out what the gradient is and what the y-intercept is. And when we sketch it, we will get a straight line. But there are many other kinds of graphs that are not straight lines. And the first one today that we're looking at is a parabola. And the parabola is the graph I get if I square my x value. So you can see the example I've written there is y equals x squared. So what we're going to start by doing is plotting this graph. Now, what I want you to do, I'm going to do the first one as an example for you, but then I want you to pause this video and fill in the values for what you get for y if I start with x squared. Now, one thing I want you to remember is if I square a negative number, I get a positive result. So if I look at the first one, when x is negative 3, when I go y equals x squared, negative 3 squared gives me 9 because negative 3 times negative 3 is 9. So now is the time to pause, and then when you hit play again, you'll just see me filling these in. Okay, you've paused it, you've done it yourself, and now you're back. Negative 2 squared is going to give me 4. Negative 1 squared will give me 1. 0 times 0, of course, is still 0. 1 squared is 1, 2 squared is 4, and 3 squared is 9. So now let's look at what we have here. We end up with a pattern, and that happens because of the squaring, that all the results for my negative x values and my positive x values give me the same answer. So negative 1 squared gives me the same as 1 squared. Negative 3 squared gives me the same value as positive 3 squared. So that's where we get symmetry from on our graph. So the next thing we want to do is plot these values on the graph. Now I've done some axes here, but there's no scale. So what you might want to do if you're going to do this with me is, first of all, is just pause again and just draw yourself a set of axes. But notice I didn't leave any room down here in the negative region because there are no negative y values. I don't know if I've got enough to go quite up to 9, but I'll nearly get there. All right, so you can pause it again and then you'll see me coming back to do this. Okay, so I have actually extended my graph up just a tiny bit to make sure that I can fit in this 9 up here because my highest y value is 9. But sometimes with a parabola, it will happen that you don't have space, and that's nothing to worry about too much. So I'm now going to plot. Now remember that these go together. So my first point that I plot is going to be negative 3, 9. So that means the x value will be negative 3 and the y value will be 9. So I just plot in the usual way. I go out to negative 3 and then I go up 9, and that brings me to this point here, which is negative 3, 9. I don't need to label it on the graph. My next point is negative 2 and 4. So that's x is negative 2 and y is 4. There it is. The next point is negative 1 and 1. So I go x is negative 1 and y is 1, and there. My next point is 0, 0. So I put that down here on the origin. Then I've got 1, 1, 2, 4, and 3, 9. Okay, now this, I don't want you to do this part, but I want to show you if I was going to do a kind of dot, connect the dots activity. Oh, I put that one in the wrong place, didn't I? It looks wrong, I can see. Let's fix that. It should go here. Okay, so let's pretend I was connecting these with a straight line. What would it look like? So let's just join these up. I don't want you to do this, just watch. Join it up, right? Each of these are getting joined with a straight line. Whoops, that last one didn't work. So what you can see is, obviously I can't get one straight line, and there's a little corner at every point where the gradient of my graph changes. But a parabola doesn't look like this. It's not a collection of straight lines. It's a smooth curve. So let's do it again, and this is going to be a bit tricky for me to do freehand on my computer, but see how I go. I'm going to try and draw a parabola shape with these. Okay, so let's go. I've missed Okay, my second half is much better than my first half. I missed this point and I've got a bit of a wobble happening here that I don't like. I'm going to just pause it for you and try again. Okay, it's still not great, but maybe it's slightly better. So there's our parabola shape. Now I'm just going to pause it again. I'm going to show you something different. Okay, so what I'm showing you there is the same graph, y equals x squared, but drawn by a computer, which is much, much better at doing smooth curves for me. Now, I want to point out a few things, right? It doesn't look like a semicircle, right? So these sides never go quite up vertically, and it's actually quite flat and rounded down here near the tip. If I zoom in just to that part down there, let's zoom in a couple of times, you can see that it does look kind of like a nice big round bowl here. But if I zoom right out and keep zooming, then as I get further away from that place where the graph dips and turns back up, these lines look quite straight. Okay, now there are a few other key points that I want to point out to you about the parabola. So let's bring these other notes back. Are they going to come back? There they are. So one is, as I've just pointed out, this parabola has a point where it turns. Right down here, the graph on the left-hand side is going down, 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 and then it starts to go up, 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 up. So we call that point, surprise, surprise, the turning point. And it's a key point for any parabola. It helps us to locate the parabola on the graph. And it's a key feature of the graph. And if you ever can, then you should always label the turning point of the graph. Now, the other thing that I want to point out to you is that we have also here, if I draw, oops, I missed, hang on. If I draw a vertical line right down through here, this is kind of like a line of symmetry. If I just pick any spot and I go the distance out to the right compared to the distance out to the left. Now I did draw this by hand and it's a little bit wobbly, but theoretically those distances there are equal. And if I folded this parabola in half, a bit like a birthday card that's been designed to meet up on both sides, then the left half of the graph and the right half of the graph would meet up perfectly. So this line has a special name and it's called the Axis of Symmetry. Now these are two terms that you need to know. It's not part of this chapter, but when we get more into quadratic graphs, you're going to need to know the turning point and the axis of symmetry. So the axis of symmetry is a line and the turning point is a point. So in this example, the turning point is at 0, 0. So if I'm asked what is the turning point, I would always give a coordinate pair with an x and y value. If I was asked for this axis of symmetry, it's a vertical line, which means it's got the form x equals something, and this particular vertical line goes through x equals 0. So that is the line of the axis of symmetry. So they're two key skills that you need to know. All right, that is it for our introduction to plotting nonlinear graphs.